Okay, so we're moving on to Unit 1, Lesson 2, Order of Operations and Evaluating Expressions. So we're going to be simplifying different types of expressions today. The first type of expression we're going to look at is something called a power, right? And we use powers to shorten how we represent repeated multiplication. So if you look at this expression I've got here, it's 2 times 2 times 2 times 2 times 2 times 2. So I would rewrite that using a power as 2 to the 6th power, right? So these powers have two parts, a base and an exponent, okay? Base and exponent. We're going to read 2 to the, right here, this expression, 2 to the 3rd power. I would say 2 cubed, so something to the 3rd power is cubed. You read this one, this expression is 5 to the 2nd power, or 5 squared, right? So moving ahead, we simplify a numerical expression when we replace it with its single numerical value. So we just perform operations. 2 times 8 is 16. That is a simplified numerical expression. So for our first problem, our first example today, we're just simplifying expressions that include powers, or that are made up of powers. So 10 to the 7th power, I can rewrite this two ways. I just want to show this to emphasize that repeated multiplication. 1, 2, 3, 4, 5, 6, 7. So I write that repeated multiplication 10 with 10 factors of 7, or 7 factors of 10, sorry, 7 factors of 10. So simplified, 10 times 10 times 10, doing this is going to be essentially a 1 with 7 zeros after it. So that's 10 million, all right? So 10 times itself, you think 10 times itself with 7 factors of 10. Okay, next one, 0.2 to the 5th power. We could rewrite that repeated multiplication, but if we think about it, this is a nice thing to be able to use a calculator for, 0.2 to the 5th power. And I can show you how to put that in a calculator. 0 point, I'm going to have 1, 2, 3 zeros, 3, 2. And that is simplified, okay? So I'm not going to require you to write the repeated multiplication, but it's just a nice thing to keep in mind, to know what a power means. So 10 is the factor itself. 7 in that example is the number of factors. 0.2 is the factor we're multiplying, or the number we're multiplying. 5 is the number of factors. So it's 0.2 times 0.2 times 0.2 times 0.2 times 0.2 is 0.00032. So these got it questions, these are a good chance for you to stop, pause the video, work through them, and then I will show you my work, and I'll show you the answers and I'll explain my answers. So I won't really show me working through it, but I will show the answers and how I got there. So pause the video. In about a few seconds, I'm going to show you my solutions. Okay, so here are my solutions, and I'm just going to do a quick explanation of each. So part A, and this got it, 3 to the 4th power is 3 times 3 times 3 times 3. I can do that, or I can just punch in 3 to the 4th power in my calculator. And you're going to look in your calculator for a button that looks like a little mountain. Call it a caret. So I would do 3 caret to the 4th power. Okay, some calculators are different. I can show you if your calculator is different. B, I have a fraction now. So fraction, I would kind of like you to be able to multiply some of these fractions, which this one's not too bad. It's 2/3 times 2/3 times 2/3. So all I did to find that new fraction was take 2 times 2 times 2 is 8. 3 times 3 times 3, 27. 8 over 27. That is simplified. And then C, 0.5 cubed, 0.5 to the 3rd power is 0.5 times 0.5 times 0.5. No shame in using a calculator on something like that. 0.125. So, big thing here in our essential understanding is thinking about simplifying an expression and we're performing that order of operations. And I believe you have some exposure to order of operations. So hopefully this feels a little bit like review. So there's really two operations happening here, and you have to do those operations in the correct order. Now, if I do the operation of adding first, that's actually incorrect. Our order of operations tells us to do multiplication before addition, even though the multiplication's on the right. So just keep that in mind. And I've got a quick refresher down here of what you do in the order of operations first, okay? You do those grouping symbols first, parentheses first. So parentheses and brackets. Then you simplify powers, then you multiply and divide from left to right. Multiply and divide, you don't multiply before you divide. Those are equal to each other. So you do the multiplication or the division, whatever comes first, left to right. And then finally add, subtract from left to right. So just make sure that we're following those orders of operations when we're simplifying some more of these numerical expressions. So in problem 2, I'm simplifying this expression. From our order of operations, I look for parentheses first. There is something I can simplify inside that parentheses, 6 minus 2, which is 4. So I'm just going to rewrite my entire expression, but with the parentheses simplified. So from this point, I've got a power. 4 to the third power is 64. Keep everything else the same. And then my last operation is to divide by 2. So my final simplified version of that expression is 32. So I did parentheses, did my exponent, then I did the division. Now, this is a good example because this has what you would think of as a fraction. I think of it as division. So when we look at this, you'd think, okay, I do the power first, and you're actually right. But really what I want to do is I want to think of any kind of fraction, the top and the bottom. Just imagine the top and the bottom each being within those grouping symbols, within those brackets, whatever you want to call them, but in those grouping symbols. So I would simplify the top first. So I would do 2 to the 4th power is 16. So I rewrite this as 16 minus 1. I'll just keep that in parentheses for now, divided by 5. And I would simplify that top of the fraction first, the top of the division first. So 15 divided by 5, and that's 3. So anytime you have a fraction like that or a division like that, simplify the top, simplify the bottom, then that last step here would be to divide. So we think of these as being kind of trapped or kind of in grouping symbols, okay? So now, when we talk about this got it, again, pause the video, work through all 4 parts. When you resume the video, I'll show you my solutions. I'll kind of explain how I got there. Okay, so here are my solutions for the got it problems, and I circled each of my simplified versions of those expressions. So a quick run through of A. I took care of the 4 squared first, and that was 16. And then I took care of my multiplication because I had 5 times 7 and then 16 divided by 2. But I read that multiplication and division from left to right. And then I took care of 16 divided by 2. And then I subtracted in the end to get 27. Part B, I only had 2 steps. I did the division first to get 5, and then I subtracted 12 minus 5. Pretty simple. For C, that's a really important one. I need to simplify the numerator, the top, and the denominator before I can divide and simplify that fraction. So I did the exponent on the top. I added together 4 and 81, and then I did 7 minus 2 on the bottom. And then I divided them. So in that reasoning part, how does a fraction bar act as a grouping symbol? We need to simplify the top and the bottom of a fraction, the numerator and the denominator, before we divide that fraction and simplify it. Okay, so that's an important thing to deal with fractions. So now you're ready to move on to the next step, the next activity in your lesson. Keep working through, ask questions, and I'll look forward to answering your questions and helping you out in the next part of this lesson.